than anything. Scared to go. No, you don't.
All right, good evening. Let's go ahead and get started for today. All right, so on Tuesday we looked at searching algorithms. It kind of makes sense now to look into sorting algorithms. All right, sorting algorithms are kind of a little bit more complicated, kind of a little bit difficult when it comes to sorting versus searching. So try to focus more on these ones. These are kind of first time they're kind of hard to grasp what's going on. Because of course it takes a lot more steps and it takes a lot more computation to sort something. Okay, so we'll look at 3 sorting algorithms. There are quite few more algorithms, but for today's class in this scope, you're going to look at 3 main ones. We'll look at the first one that we are going to look at is called selection sort. Okay. The second one is insertion sort. Okay, and then we are going to end the class with quick sort. This is better of all the 3 algorithms that we are going to look at. It's also more complicated than the other 2 also. Okay. All right, before we begin, what I'm going to do is I'm going to slack out some numbers to you guys, and I want you guys to sort those numbers by hand. Take a paper or a pen, paper and pen, or do it on your computer, but don't use any sorting website or anything. Do it by hand. And what I'm going to do is whoever finishes first, just raise your hand or yell or something, call out. And I'm going to start a timer, and I'm going to stop and see how much time it takes for us humans to sort that out. Okay? You want paper and pen?
Yes.
Well, I have some. I have 3 pens.
Put my laptop at home. Anybody else needs? Good.
Okay, so I'm going to slack these numbers out. So whoever completes first, please raise your hand or get my attention so that I can stop the timer here. This is going to be my timer. What was that? Slack it back to me.
Cheating.
Hold on. Or just say you're done or something. Just like something like that. Okay.
Being lazy and just typing up.
Typing what?
Typing the numbers off the keyboard.
I didn't get it. How would you do that?
So, you know how you're typing out the numbers?
Yeah.
Just like typing the message like it's like typing.
No, but do it by hand as long as you. Yeah. Just slack it out. Yeah, that's fine. Huh?
That's show logic and put them in order.
No, just put them in ascending order. Like, look at the numbers and how would you sort them in ascending order. Okay?
Not with the programming.
No. Don't use any program. And we'll look at the sorting order. It kind of defeats the purpose. Don't sort it. Type it back out or no, I don't want you guys typing it back out, right? Complete the sorting and just say it's all sorted. Okay? Typing back, I understand you look at the numbers, you will say, oh, this one's smaller, type first, type second. Don't do that. I want you guys to sort it because that's not how the computer does it. It sorts the whole thing and then spits it out. No, I don't want, use whatever, use your mind. Don't give me any logic. We'll come to the logic part later on. Just sort it and say it's done and I'll stop the timer. Okay? It's creating more confusion than I expected. You good?
We don't understand this.
Yeah, it's good, but I'm like, instructions are not as clear as I thought they were. Okay, alright. So these are the numbers and I'm starting the stopwatch.
I'm only thinking about it
So you're organizing in ascending order. By hand. Yeah. All right. So Roy completed the sorting 1 minute 15 seconds. Dylan is done. Will, you're also done?
I'm not here.
Olga is done. Kind of like under 2 minutes. Andres, George. Fernando. Anthony, good. So it's kind of fair to say like under 2 minutes or at like 2 minutes, people went ahead and sorted. I don't know how many numbers are these? 10, 12, something? Okay. Roy, since you were the first one to complete, what was your strategy to complete the sorting when you looked at these numbers?
When I looked at the numbers, I started writing it down and I just gave myself that looks like a mess, but it's spatial awareness. So 200 was further down, so I wrote 200 down. 39 is up, so I wrote it up here, and then as the numbers came, I just went off based off of where the last number was, where it went. And
Okay.
just kept organizing it.
Okay. Yeah. Okay. What was that? What was your? I mean, everybody had a system. The only thing is you just don't realize it. What was your thing? How did you sort it out, Andres?
I looked at any numbers with 1 digits that didn't exist. I started with 2 digits and then hopefully started with the lowest one.
Okay.
I missed 48, so I wrote it down anyway.
Okay. So you also had a
I
steps,
did like
right?
the 100s and I did 200.
All right. So you also had a number of steps or some kind of logic, right? There's always a logic. I don't think there's possibility anybody solved it without any logic. What about you, Olga? How did you solve it?
Pretty much the same. Just like found 17 and was looking if there's anything higher than the next one.
Okay.
I think they're all, yeah.
Okay. So you looked at the smallest one, then the one higher, then one higher. So we looked at the steps for searching also, right? For humans, this is how we search, and then we made an algorithm, and we taught the computer to do the same thing, right? So it's the exact same thing over here. So we looked at some of the sorting methods. A couple of people shared. And this is how sorting was born also, right? How do you teach the computer to do the exact same thing, right? And these are the three that we are going to see. There are more, they're like 7, 8, 9, and people are coming. So we came up with a algorithm, the basic one, right? As you guys were saying, you look at the numbers, try to find the smallest one, then find the next one that is bigger than that one, but still the smaller one, and then kind of put them in ascending order. Okay, that is exactly what selection sort is. Okay, what selection sort does is it selects the smallest number in the array. All right, it looks at an array. Let's see, let me put some numbers here. Okay, this is the same site that we saw. It's a very nice site and kind of gives you an idea how these work. So I have 3, and I have 44, 38, 5, 47, 15, 36, 36, 37, 2,
46,
46.
4, 19, 50, and 48.
Okay, thank you very much. So I have these numbers, right? So what selection sort does it is exactly how you guys were thinking. Selection sort starts from here and then looks for the smallest number. So by default, what it does is it has to pick one. So it says, okay, I'm going to start from here. I'm going to assume that the first number in my array is the smallest number. Okay, so right now 3 is the smallest number, and then it goes to this each element and tries to find a number that is smaller than this one. Goes to 44, nope, 38, 5, 47, 15, 36, blah, 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 comes to 2. Okay, and then it kind of keeps track of this one, right? And then keeps going. And then it says, is there any number that is less than 2 now? So it started from here, found 2, so now the new minimum is 2. So then selection sort continues and says, is there a number that is less than 2? Comes here, end of the array, it doesn't find it. Right? What it does is then it knows that 2 is the smallest, it picks 2, puts it over here, and picks 3 and puts it over here. Okay. Now my index, this is 2 and this is 3. Okay. Now everything over here is sorted. You have the smallest number possible in this array, and this part, this end is kind of sorted right now. Okay. This is done. It moves on to the next index. Starts with 44 now. It says, okay, I'm going to look for a number that is greater, it's not smaller, it's not possible that there's a number that is smaller than this, so I'm going to find a number that is the next smallest. Okay, started with 44. 38, less than this, okay. So maybe 38 is my next smallest number. Why? Because it's okay. Then it goes and tries to find the next smallest. It says it finds 5, which is less than 38, which was the next minimum. Okay, keeps going until it comes to 3. Right? It reaches the end of the array, and 3 is the next smallest integer. Okay, what will happen? Picks up 3, puts it over here, picks 44, and puts 44 over here. Kind of swap. Right? So now I have 3 here, and then I have 44 here. Okay? This iteration is complete. Comes back to the second index, or the third index, but index number 2, 0, 1, 2. Okay, start with 38, goes through the whole array and tries to find a number that is bigger than this, okay, but still smallest in this remaining array. Okay, starts from here, goes through the whole array and finds 4. Okay, and then it's going to do the same thing. So 38 becomes 4, and 4 is 38. Okay, comes back here again, starts from the same thing again. All right, so you see what is going on? Continuously, it's trying to find a number that is smaller. Okay, and then eventually what will happen is it will pick, and then it's going to sort the whole array. All right, let's take a look at this. This will be probably faster than my typing. So start with 3, goes through the whole thing, finds 2. Okay, so it says, okay, so till now I found a number that is less than 3. Okay, it keeps a check on it and then keeps until it reaches the end of the array. Okay, and then it says, okay, so this is, I've determined that 2 is the smallest number, so it's going to swap these 2 numbers. Okay, comes to the next one, 44. It's going to now go and find in the remaining array if there's any number that is greater than 2 but still smaller in this array. So keeps going. 38 checks. So 44 is our thing that it is checking. So it says, okay, 38 is less than 44. That's my new smallest number. Checks with 5 against 38. Okay, 5 is my smallest number till now. Okay, keeps going. 47, bigger than 5, doesn't care. 15, don't care, don't care, don't care. 3. 3 is smaller than 5, so 3 is the new minimum, right? It's still determining what is the smallest number, and when it reaches the end of the array, then it's going to confirm that this is my smallest number. It's not going to, it's just taking like it's bookmarking this. Okay, right now 3 is there, but there might be something that is less than 3. Keeps going, keeps going, keeps going, keeps going. End of the array, 3 is the smallest number, comes back, swaps it. Okay, goes on to 38. 38 is my smallest. It starts with the assumption that the first one is the smallest. It's going to find any number that is less than 38. 5. Okay, 5 is smaller. Kind of makes a bookmark, goes through and tries to find any number that is smaller than 5. 4. Checks it. Okay, keeps end of the array. Comes back, swaps it. Okay, comes to 5, tries to find something that is smaller than 5. Nope, so it's already in the right place. Comes to 47, 15, swaps it. Okay, it's going to keep continuing until it gets to the end of the array. All right, any questions on how this is working?
Similar to what we learned in last class, like linear. It's like going through each number.
Correct. Yes. The only difference is that was a search algorithm, this is a sorting one. But yes, it is going through each one. Okay? Alright, so by the end of the array, this is how it's going to look like. It's going to sort everything. Okay? Now, the question is, let me go back and restart this. What is considered the best case scenario over here?
If they were already in order.
That's correct. If they are already in order. If the array that you're trying to sort is already sorted, that's the best case scenario. What's the worst case? Yeah, reverse order, that's the worst case, that everything is like descending order, you have to do it ascending. And this can be considered like average case. Okay, if you add some numbers that are next to each other, some of them are sorted, but a lot of the array is not sorted, that's kind of considered the average case. All right. So we saw linear search, right? In best case, there were smaller numbers of steps, right? Something similar. What will happen in the best case if I give this completely a sorted array? It still has to go through each one of them. Yep. It will go through each one until it reaches or it completes as so you see, it will go through each one. It doesn't care if they are sorted. It will go through each one of them. Okay. So this is the reason why selection sort is kind of considered the worst sorting algorithm, because it cannot differentiate if the array is kind of sorted, average sorted. It doesn't matter. You give it a completely sorted array, or you give it a completely unsorted array, or an average case. In every case, it's going to have the same steps. Right? It's not going to reduce any number of steps for you. Okay? That's why it is kind of... This is a good... You guys will see this more on Saturday. But let me show you this one. Where's my selection sort? You see this? Oops. Red, 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 red across. This is basically saying it doesn't matter what kind of an array is, if it's a best case or worst case or an average case, it's going to have the same amount, it's going to run the same amount of steps and same amount of time. Okay? And if you see, it says n to the power 2. Oops. And this is the graph for n to the power 2. You see, a small number of set is going to take this much time. Kind of goes up. For practical reasons, you can see it's not reasonable. You cannot use this in any kind of an array that you're trying to sort. Maybe a small array, but still going to take the same time, right? So, but this is the basic one that we started as humans. We guys were searching. You guys were kind of on this one. We'll see this one. This is also more human intuitive. But that's how we came up. And remember, I used the word brute force. This is what brute force kind of look. We looked at the linear search, then we are looking at the selection sort. So this is the basic, the bare bone algorithm that we start with. Okay. Now, when you are doing your interviews and you get like a kind of whiteboard, they tell you, they give you a problem, and they ask you for a solution. Usually, what happens? The first solution that comes to mind for any issue is brute force. That what's the simplest way I can do it, but that would be probably the most inefficient also, right? So you kind of have to get in a habit. It takes quite a practice that you do not write the brute force or the basic solution on the board. You kind of talk about it. You say, oh, this is what I'm thinking, but this is more inefficient and brute force. Okay, and the interviewer will be like, okay, yeah, I get it. That's good. Now, how are you making more efficient? So kind of save that time instead of writing the whole thing out. And by the end of the, when you are end of the solution, the interviewer tells you, well, I get it, and it will work, but that's like the most inefficient. That's like the brute force, right? How can you make it more efficient, right? The better way I found out is talk about that brute force solution, and then try to think a more efficient solution. Okay. All right. So on this one. So let's go back. Let me see if I can get back those numbers. Okay. Skip this. Go back to selection. Okay. So what is happening? How many loops there are? The first loop is to loop through the whole array. Okay, that's your first loop. Let's begin from the first and goes to the last index. Okay. Then there's a second loop that goes from this to the end of the array, or this to the end of the array, or this to the end of the array, this to the end of the array. Okay. This means it's always kind of one more than whatever this index is. Okay. So you can say it's plus 1 from this one until the end of the array. Okay, so two loops. The first one is running the big one, and the second one is running the remaining ones. All right. And what are you doing? You start with this one. You say, oh, my first index. When you start the first loop, you will say, this is my minimum. I'm considering this index as the minimum one, and I'm going to check this index against everything else. Okay, so if condition, you're checking if this is really minimum, and if you find the minimum, you kind of update your minimum index to the new value, but don't do anything, just keep a track of it, right? But when you reach the end of the array, when you have sorted, when you have reached this loop, when you have completed this loop, what do? You kind of swap the numbers. All right? When you're swapping this number with the minimum one. Okay? That's kind of the basic concept of it. All right. Anyone wants to take a stab at it? Should we do a pseudocode? This is probably the easiest one among these three. All right. Anybody? So this would be the kind of pseudocode. You can take a look at this also. This is a little bit different. But what's happening is, consider that you already have a function given to you, swap function. Let's suppose takes an array and two numbers, num1, num2. Okay, what it will do is it will swap these numbers, so you don't have to worry about writing this function. Basically, just call a function called swap, and we can go with the assumption that the two numbers that you're passing in, it's going to swap those two numbers. Okay, so when you write your code, you can just say, oh, swap, and I would say, okay, so at this point you are swapping those two numbers, so you don't have to worry about writing like how are you going to swap these numbers. We don't have to worry about this one. The only thing we are worried is writing this algorithm. Anybody wants to take a try? Kevin, you seem like you're interested. I can tell. I can. What was that? You're least interested.
Browsing memes back here.
So you are the excellent candidate to come and do this one now. Yeah. All right.
No pressure.
No pressure.
We're gonna stare at you.
Yeah. Well, you'll have help.
You're gonna do it with me? Great.
Yeah.
Perfect.
Everybody, the whole class is doing it here.
So what do you guys think?
I'll do it here. You can look at them.
2x plus y.
Passport. Use the array.
Start with an array. So
Well,
you
start
want
with
to
the-
actually write out all the code, yeah?
Yeah, let's
Okay.
start with the function name. Let's say function
Okay.
selection sort.
So
Yes.
call const.
Be ready for the insertion sort now.
That's gonna be fun.
Okay, I'm gonna find it right now.
So
Yeah.
let's take a look here. We'll start with a for loop. Yeah, I guess we could do for each. Yeah.
Yeah, start with for loop. Keep it simple.
So okay. So for what's an I equal 0. It's less than. And then we're gonna write another for loop. We'll call this one, what's after I? H?
Sure. Yeah.
H was 4,
H is what?
What's that?
It's J, bro, but we're good.
J? It's a trick. I was doing it backwards. This is a sobriety test. Just wanted to spell high, that's all. Sorry, having a little slack here. For
Yeah.
I equal I plus 1, and then we would be going from there to r dot length minus h, right? So if we start at 0,
Yep.
this is 1. No, we're going to the end of the array.
Yeah, you're going to the end
Okay.
of the array. That should be it.
H plus open bracket.
Okay, that's it.
So then, if
Oh, before the if statement. So
Yeah.
you need to pick.
I need
the
to have a minimum,
first.
or yeah.
Yeah.
So const min is equal to r square brackets I.
Okay. Now you want to pick the minimum when your array begins, the first one, right?
Right.
So you are here. The second loop is for a subset, right? We start with the minimum.
You're right. Okay.
So
So
you just
this
move
actually
into
needs to be in the.
You're right.
Middle,
One up.
You can just
So
put it above your
this is
other
a little
Yep.
caret here.
Yes.
Const what do they call it? Min.
Yeah.
Equals r I.
Okay. Yep.
And then, so, let's say if r h is less than min, then swap with array, and then see min and r. Well, I guess it would have to do array I, huh? The min is just holding the value.
Okay. Yeah. So you are doing the swap. Swap would change these numbers. Okay. Remember when we are at this point 44, it will find this minimum, right? It's less than 44, but it's not the smallest number. It's going to swap right now. We want to keep a placeholder. We want to swap when we are completely 100% sure that this value is less than.
Oh, you're right. Okay, so now I need to hold a second value. No?
Just update the minimum.
What's that?
Just update the minimum.
Oh.
So you will say, oh, this is my new minimum.
So
But
now,
I'm not sure yet. But when I reach the end of there, then I'm going to swap my minimum.
I see. So minimum is now equal to
Yeah.
r h.
Okay, so now we have a new minimum.
So now it gets all the way through and it picks the minimum, and now we swap.
Right. When your loop,
So
the first one ends.
gotta see our bracket there.
Yep.
See that one.
Yep.
And then would swap with array, and then we're actually passing the indexes, right?
Right. So you are swapping with the first loop index, which is your I, you called it,
Right.
and with the new minimum that you found out.
I and then right, and then
Yep.
that would be the end of the loop here. And another one, right?
Yeah, the function should do it.
And it.
That's it.
Anybody follow along with me? Let's see if it's right.
Thank you. Thank you.
There's just one thing.
Sure.
You're comparing in your if statement, you have RH is less than min. Min is the index, not the value.
You're right. So I need R min.
Yes, you need R min.
Okay, so you're right. So
So you
yeah, because I've got this. I actually put the value in there, but what I want is the index.
Yes.
Ah. So min is equal to I, and then I need to compare R min. The actual value's there. And then, let's see. I just want min to become the index here, right? Good catch. Okay.
Thank you. Thank you. That wasn't that bad. To be honest, I couldn't have written this if somebody else. I have to do rigorous training and understand, and then I can do it. But it takes a while for me to practice for the whiteboarding sessions. So that is a selection sort, and it is probably the worst sorting algorithm to use. All right, but it is kind of easy. It kind of gives a warm-up exercise. You kind of know, okay, what's going on? How do you sort stuff? Kind of gives you an idea. But then it kind of opens up, okay, how can we make it more efficient, or how this has been done? So remember, the definition of algorithm in computer science was that you look at the problem, and there might be a solution. But finding a better solution is also part of creating an algorithm. And that's what happened. Somebody came up with this, and they said, well, this is too bad. Let's try to find a different algorithm. All right? And that's how we come to insertion sort. So insertion sort is more, what we call is more human intuitive. And kind of, some people use selection sort as a strategy to solve by hand. And some people kind of use insertion sort. All right? So let's take a look how insertion sort works. So in the same one, let's go over here. I'm going to show this over here. It's kind of easier to show over here than me writing this whole thing out, especially for sorting. And this is a good visual, so it should still be kind of easy to follow. All right, so let me pause this. Let's go back. All right, similar to selection sort, insertion sort starts with the first one, okay, and then it goes to the next, to the end of the array. Let's see what's happening here. My kind of minimum is 3, starts with the first one, so it says, okay, 3 is minimum, and then it goes to the next number, okay. It says, is 44 less than 3? No, it kind of puts it back in place. All right, goes to the next one. Okay, so at this point, is this part of the array sorted? It is sorted. All right, so insertion sort is basically checking the numbers behind it to see if they are sorted. Okay, we'll see. Since this was a small set, we didn't really see what happened. Let's look at the next one. So at this point, at 38, it's going to see and make sure that everything before 38 is sorted, including 38. All right. So the first thing it checks is neighbor, the previous neighbor, and checks if it is sorted. It says, okay, 38 is less than, so I need to swap these two. Okay. Now it goes back and says, okay, this is not sorted. What about the one previous? Until it reaches 0. So is 38 less than 3? Nope. So this is the right position of 38, puts it here, and this part of the array is sorted. All right. Now it will go to 5. It's going to check 5 with its neighbor, 44. Nope. Swap it. Now it's going to go back and check with 38. Nope. It's going to put this in the right. It's going to check with 3. 3 is less than, yep. So this is the right position of 5. It's going to put 5 here. All right. Let's take one more. 47. Checks with 44. 44 is already less than this. Okay. Does it need to go back and check all these 3? No, not really, because insertion sort is kind of guaranteeing that if the neighbor is already less than, everything before it already sorted. Okay, so it's not going to, it checks 44, it's already in the right place, kind of stops over there. Okay, let's take a look at 15. 15 will now check with its neighbor, and then if it is not in the right place, we'll check its neighbor and keep going until it finds a number that is smaller than this. So 47, nope, keeps going. 44, nope, keep going. 38, keeps going. 5 is less than, so it doesn't have to check 3 anymore because it kind of guarantees that everything before 5 is less than this number. Okay?
It's always going to go to the left.
It is always going to go to the left. It's going to go -1. It's kind of going this direction. Okay? Now we move on to the next one. 36. Oops. Checks with 47. Less. Comes back. 36. Yep. 15. Puts it over here. Let's start with 26. 47. Swaps it. Comes here. Keeps going. 15. Kind of guarantees that everything before 15 is less than 26. Okay. Let me go to 2 because that's the 2 has to travel a lot, so this would be kind of more easy to see. So it checks 47, keeps going until it finds a number that is less than it. It reaches the end of the array. So what are the 2 conditions? The first condition is the neighbor, let's say I minus 1, is less than the current number. Okay, the current number is 2, so keep going back until you reach this condition, or I is equal to 0, or you can say -1, which means is I have reached the beginning of the array. I don't have anywhere else to go. I cannot go more left. All right. So these are the kind of 2 conditions that it will. So this time 2 reaches to the end of the array, and it says, okay, I've reached to the end of the array. There's nothing more to look. I'm going to go ahead and put 2. Okay. 47, and then it's going to sort everything out. Okay. What questions do you guys have? So this is kind of considered more human intuitive, and I was hearing you guys people solve. A lot of people solve the ascending, the sorting using this strategy, and so it's kind of more easy to understand. Of course, it's kind of more, not as difficult, but more difficult to implement than the brute force one, but easier to see what's going on. Okay. Let's see what so the 2 condition I was saying, until if you are going this way, so we start with same thing. We'll have for loops. Okay, for and a while. You can use it with 2 for loops also, but imagine if you are here, you want to go all the way back. More sense is to use a while. That while, like until you reach the end of the array, or you find a number that kind of qualifies as a minimum, keep going back. Okay, so there's the for, and then there will be a while. The for is to go through the array, and the while is pick a number and keep going back. Okay. So my for loop starts from, what would be my starting index? Let me unsort this so that, okay. What's my starting index of the array, the algorithm? What's my starting index? Is it 0 or is it 1? You can start with 0, but the reason would be that 0 index we are considering is already sorted. You see?
Can't go backwards.
You can't go backwards. So it's kind of waste of an iteration and nothing is going to happen. So we kind of skip the first one. You see it started with the next one. And that's the reason, because 0 at this index, it's kind of sorted anyway. There's no way, it cannot go back, as David is saying, it kind of stops over here. Okay? So to save that iteration, we start from 1 and goes to the end of the array. Okay? Whatever the length of the this index number. Alright, everybody good with this? Kind of get the idea? It's kind of, we're skipping the first one and starting with the next one. Okay? Now, let's call this I, and the next one is J. This is the one that's going back. Okay? Now I'm saying keep going back or keep executing. Keep going back until you reach the 0 index, and that's what the while is for. While this index is greater than 0. Okay? Now keep going back until I reach 0. Okay? And how and what's the other condition I said? We are comparing, right? Let's go back here. This is 15. So until until this element is less than what we are trying to compare. Okay? So it could be until this array, right? And the one behind it. Okay, the one before. So I plus 1 would give me this one. I minus 1 would give me the previous one. Okay, you can say I minus 1 or the previous is greater than my current one. Okay, as long as this is true, I want to keep going back, right? I want to keep going back until this is kind of working. Okay, so you keep going back. And then when you exit it out, what do you want to do? You want to use the same swap function and then swap those numbers. Okay, let's take a look at this. Keep going back until you find it, and then swap this number, put this in place. Okay, I know the animation is kind of moving things around, but for simplicity, we can consider like a swap function that kind of moves the things around and kind of puts the number in its place. Okay, let's see if I have. So you're going to swap my current with previous number, which is these two. Okay, and my y will then end over here, and this should keep going for the next one. Okay, let's see. It's kind of similar to this one. You see this pseudocode says from the sorted from this one until it reaches 0, and then my j is going to be whatever this iteration is. Okay, so this is the number that I found out, and I keep going back. Swap those number, and you need to reduce the value of j also. Okay, if you do not, you're just going to go in an infinite loop. So j minus minus you can do, so that it kind of keeps reducing, and then swap the numbers. Okay, that's kind of the pseudocode. Now, question about this. What do you have any questions about how insertion sort work? Okay, insertion sort is better than the selection sort. If you see the best case, if the array is sorted, you can kind of imagine that it doesn't, it it kind of if it's already sorted, it kind of determines it that it's already sorted versus the selection sort, which would go through the whole thing irrespective. All right, you guys see the point that if it finds this number which is already less, everything before that is less, so it kind of stops over there. It says, oh, if this is already the smallest number, everything before it is already small. This means that it's kind of area is already sorted. It kind of stops over there. Insertion sort. Okay. Worst case, descending order or average case, still kind of bad. But we will see that most of the algorithms that are being used kind of mix of insertion sort and quick sort. I'll give you an example towards the end of the class. Okay. Anybody wants to whiteboard this one? Fernando. You already remember the algorithm now? Kinda.
Pi. That's the answer, right?
Huh?
Pi.
Pi?
That's squared. That's right.
You want this or should I remove it?
Yeah, let's keep it.
Okay.
Alright.
You can remove this array if you want.
So let's see. So this is basically still the rule set. I just have to.
Yeah, just write it in proper code.
Okay.
Alright, start with the function name. Put the function name, write the for loops correctly, like for let I is equal to 1 to end of the array. And then just swap this with
I'm gonna put it on this side of the board.
okay.
It's gonna be. Those are my curly braces. It's gonna be 0.
So we'll start with I is equal to.
Oh, it's equal to. Sorry.
Now that's good. And remember we are saying we are going to skip the first one because there's no use in checking one. So we'll start with I equal to 1. Yeah.
And then it's gonna be.
Well, the next one is the plus plus part.
Yeah.
So we'll do I plus plus and then okay. So you have to put a condition. Array dot length is correct, but in the middle you have to put a condition. So it's going to be I is less than yeah.
Okay. And then in here is going to be.
So this is yeah, this will work. I is less than okay.
And
So
we'll
you
use the
completed
while.
this part.
Yeah.
Okay. And the next you are going to check the condition. So you are already looping through this now.
Mhm.
Okay. Let's suppose you are on number 38.
Okay.
Okay. So
That'll be a while, right?
right. You write a new
Letter.
variable name.
J is equal to.
Well, now while takes a condition.
Oh, while it takes as a condition.
Yeah, you are right. So it can't be assignment. It has to be like a condition. What do you guys think will be the condition here?
Greater than 0?
Yeah. So we are at this point. If this is my j, and I want to keep going back until my j value, which is the index, is greater than 0. That's good. And how far do I want to go back? I'm comparing the two numbers, right? So what's going to be that condition?
So it'd be array I minus 1 is greater than array 1.
Yeah. So my neighbor, as long as my neighbor is greater, I want to keep going back and find the smallest one.
And then that closes the brackets.
Yep.
Now I'm over here. My neighbor is, let's say this one, 26 and 47, right? My neighbor is greater than my current position. What do I want to do? I want to
Swap.
swap these two.
So that would be
You can just call a function saying swap and then pass in two numbers, my previous and current, and then we can assume that it has swapped the array, the number has been swapped.
that would be j, right? Or would it be
Yeah. It's going to be the same condition that you wrote on the top.
Okay.
AR array I minus 1
with
with the current array. So array, you can say
okay.
okay. So now I'm here. I swap these two. Everything is good, right? But I need to keep going back, right? So my while loop, I have to reduce my value of j. So you see, you haven't assigned j anything.
Yeah.
So the assign, where would the assignment go?
Would be right in between right here, right?
What do you guys think? Where would the assignment for j be?
Before the while.
Before the while.
Before the while.
So you're going to say j is equal to
So uppercase, that's always been my issue. J is equal to
so let's suppose I'm on this index. This is my 0, 1, 2, 3, 4, 5, 6 index. Okay, I say this is my I also and this is my j also at that point. Okay, now I come in my while statement. I want my j to keep going down, 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 down. Okay, so I'm going to keep reducing my j. Right now j is 6. It has to be 5, 4, 3, 2, 1. So you
that'd
got to find, yeah, j is equal to I.
j is equal to I.
Right? So at this point, my both j and i's are 6. Okay? I swap them and I also reduce the number j. So after the swap,
Do semicolon j minus minus.
that will be after the swap. I
Oh,
cannot do
after
it
the
because
swap.
I'm still in the while. I want to exit out of the while statement, right? It's kind of will keep looping through. So once swap is done, right after swap, I'm going to
J
j minus 1. Yeah.
Okay.
And this is all in the while condition. Okay, then you can close your while loop. Yeah. And then you can close out your for loop also. Okay.
That looks so weird. Am I
You guys
done
right?
or technically? Don't I have to check for the other condition to see if it's already swapped at the end?
Already swapped at the end.
Like, not already swapped at the end. Never mind. I'll go back to my chair.
You good? Everybody good with this? Alright. It's kind of a little bit tricky when you do it first. But go back and kind of look up the algorithm again. I'll post the code and everything. Push it to GitLab. Take a look at this. Okay. So at this point we have completed these two. Alright. Any questions on these two algorithms?
How often are we going to use them?
Huh?
How often are we going to be using them?
So again, what's the use? You will probably never use it. Okay. But the understanding part, that's the part that is always tested, and that's where the knowledge comes up from. Okay. So the part of this is you are never probably going to write the sorting algorithm. There are better ways that are already done. All right. But the expectation from this is you are going to write an algorithm that would solve some other issue. Whatever project you are working on, that's what it's going to solve, right? But that algorithm would involve the same number of steps. like it won't be sorting, but it would be something else, and you'd be like, okay, how do I get to it? You would create an algorithm that would be kind of this one. What I mean is it would be a brute force, right? It would do the job, but it will never be efficient. Then you're going to refactor your algorithm and come up with a better algorithm, okay? And then somebody else might come on and then say, hey, you wrote this is good, but I think this will work even more better. And that's what the process is. And that's why they teach, this is like a CS 101 courses, and that's what they start with, okay? Again, all this, what you would be using is, and you guys have used it, you would call in JavaScript a sort method and pass it an array. Okay, and it will sort the whole thing for you. Okay, but what is important is you guys need to understand what algorithms are being used behind sort. Okay, it's interesting when you call the sort method in your browser, in your Chrome browser. Chrome calls these two, it's a combination of these two algorithms that Chrome browser works on. Okay, what it does is if the array is smaller, it uses insertion sort to sort the array. If it is larger and more unsorted way, it will use quick sort to sort the thing. Okay, that's what it is. There are even more better algorithms. You see quick merge sort, time sort, heap sort. Okay. These are more when you look at the code, you'll be like, I don't know what's going on. But the concept over here is that we started with this one, and then there are algorithms that are much better. At this point, we have much better, right? Tomorrow or somebody might come up with an even better algorithm. All right, that's a possibility. That's what keeps happening. That's what it is. Okay. Now we will see last algorithm of the day. That is probably the most complicated of all these three. So I'm going to more concentrate on showing you how it actually works, because the 90% of the effort is trying to understand what quicksort is actually doing. All right. Again, I'm not going to call anybody to come and code quicksort. It's kind of more difficult. I'll share the code, show you how the code is working. But the important part is that you understand how quicksort works and how it solves the problem. Okay. So we saw these algorithms. Quicksort, what it does is part of a set of algorithms that are called divide and conquer. Divide and conquer. What it does is it divides your array in smaller parts, okay, and then sorts those smaller parts. And then towards the end, it combines the smaller broken parts that it has divided, and eventually you will get a completely sorted array. Okay, quicksort is considered very efficient. Okay, and there are a few more that kind of flow into the same issue. All right. Again, it's part of the divide and conquer. What it does is going to take this big array, break it down into smaller pieces, and sort them. Okay. Or the other word for it is, what it does is partitions the array. Partitions the array. Okay. So when we begin with this algorithm, we find a point that you can partition the array on. Okay, and that point is called pivot. P-I-V-O-T. Okay. Now, sometimes there's a complex logic that goes into finding the right pivot. What is pivot? Pivot is one of these numbers that you can partition array. Okay, I'm not going to go into the pivot logic. How do we determine the pivot of this? But there are three basic ways you can determine your pivot. Either you can say that my pivot is my first index. This is my pivot. Or in some cases you will see my last index is a pivot, and I'm going to take this and I'm going to partition my array starting here, or I'll start from here. Or the third is you pick any random number from your array and say that this is my pivot. It doesn't matter, okay? The logic will still remain the same. What it is that it's going to take a pivot and then partition the array based on that. Okay, your pivot is keep going to change. What we need is the first time we need to assign it something. That's the only thing. Okay, it's not really important what the pivot is because this is going to change, but as a starting point we need something. Okay, so that's why we either consider the first element as our pivot or the last or any one of them. It's up to you. Okay, I'll show you the this graph starts with our first one, but the logic and everything still remains the same. So we are going to start saying that our first element is the pivot, and we are going to partition our array. Okay, everybody good with the pivot part? Pivot is just partitioning. We'll see how it partitions now. What I want is that whatever my pivot is, I want everything that is left to my pivot to be smaller than my pivot. Okay? And everything that is larger than my pivot should be on the right side. Everything that is bigger goes on my right. Everything that is less than the pivot goes on my left side. What I mean is, let's suppose I have numbers 5, 15, 2, 1, 25. Okay? And let's suppose my pivot over here is 2. Now the logic of this is that everything that is smaller than 2 should be on this side. So 5 is not good. So I want 1 to be here. And then 25 is fine because it is bigger. Then I want to move my 15. And then I want to move 5 over here. Okay? So whatever pivot that you choose, whatever the number is, in every scenario you want your numbers that are smaller than the pivot to be on your left side and numbers that are greater than your pivot to be on your right side. That's the goal of this. Okay? We'll see how it happens. But that's the concept and that's actually the logic of it. Okay? And then you keep doing this until your array is sorted. Okay? So, let's see how it works. Okay, so I'm using the first number as my pivot. So right now it's 3. Now my goal is that all the numbers that are smaller than 3 should be over here on the left side of 3. All the numbers that are greater than 3 should be on the right side. Okay? Oh, that's pretty fast. Okay, so I start with the next element. 44 is bigger than 3, so it's on the right position. It's on the right side of the 3. I don't care about that. Skip that. 38 still correct. So you see this becomes purple. I'm taking a note. This note tells me that this is the number, that the beginning of a number, that everything before that is kind of less than or equal to 3. Okay? 38. 38 is also good. 5 is also good. Everything good. Okay, until we come to 2. All right, so till now again my goal is that this is my pivot. I want everything that is bigger than my pivot on my right side and everything that is less than pivot on my left side. When I come to 2, I see that 2 is less than my pivot. Okay, so now I am going to go ahead and swap it. You guys see what happened? It did not swap with my pivot, it just swapped with the first number that it knew that everything below that number is less than 3. Okay, I'm going to eventually swap my pivot, but not right now until I reach the end of the array. Okay, I'm just moving it closer so I can move everything to my left side. Okay, but the logic is still the same, that everything less than my pivot goes on the left side. Everything bigger than the pivot goes on the right side. Okay. 46, still good. 4. Okay. Still good. Pivot is 3, 19, 50, and reaches to the end of the array. Okay, when I reach the end, this is my point. Everything greater than 3 is this. Everything less than 3 is on this side. Now I'm going to swap my pivot, and then everything on the left side is now less than my pivot. Everything bigger than my pivot is on the right side. Okay, give it a few more tries and it will make more sense. Okay, we'll do just since this is the first, it's kind of difficult to understand. We will do a few more. Okay, now we see what happened. My array has been partitioned into 2 parts, 1 and 2. Everything on this side is bigger than 3. Everything less than 3 is on the other side. Okay, so this is my pivot. Now you won't be able to see right now. Let's go a few more iterations. But now what is going to happen is I have this array and this array. Now I'm going to sort left side, and then I'm going to come back and sort my right side. I have partitioned my array into 2 parts, left and right. Okay, so it's going to sort the left. Right now it's just only 1 element, so you won't really see the sorting part. So already sorted. It says okay, everything is good. Now this side of the array has been sorted. Now I'm going to sort this side of the array. All right. And what is my condition to pick up pivot? Is always going to be my first element. Now my array is from 38 to 48. My first element is 38. So that's my pivot now. So my goal now is that everything bigger than 38 should be on this side. Everything less than 38 should be on the left side of 38. Okay. Let's start with this. Smaller. Okay. Why it didn't change the position? Because it's still there. I mean, there's nothing. 38 is my pivot. You're already not comparing with 38. So 5 is in the right position because I cannot move 5 anywhere, right? Now forget about this array. This is my array. It doesn't know that anything else exists. It has partitioned that array. Okay. We go to 47. Bigger than 38. That's cool. 15. Less than 38. So it should swap with the one where the number is bigger than 38. So it's going to swap with 47. Right? Give a few more tries and let's see what happens. 36 less than 38. Where should it swap? With 47. Because 47 is my boundary, is my margin, where any number that is bigger than 38 begins. Okay. Let's go to 26. Still smaller than 38, so it's going to swap with 47 because that's my boundary. 27 does the same thing. 44, bigger than 38, so this is on the right side. It should be on this side, so that's okay. I'm not going to touch 48. 46, still good. 4 is smaller than 38, so it should move on this side. And what's the boundary that begins for where the larger number starts? That's my 47. So it's going to swap with 47. What is my boundary now of the largest number? No, I swapped the numbers. You see what happened? This was 47 was the boundary, but I swapped it with 4. Oops. Now the boundary of the larger number is 44. I know it is 47 strip. We don't care about that. We are just trying to find the boundary where all my larger numbers that are bigger than 38 exist. Since I swapped, now my boundary is 44. These are the numbers. This is the first number that is bigger than 38. Okay, so the boundary kind of changed. Let's keep going. 19, less than 38. What's the boundary of my number that is larger than 38? 44. So it's going to swap with 44. What's the boundary now? 46. Okay, you guys see the pattern? Let's go to 50. Should stay in place. 48 still in place. Okay. Now I have partitioned my array further. All right. So now on this side, the green ones are the number that are less than 38, and the numbers greater than 38 are on purple. Okay. What is it going to swap 38 with? 19. Correct. All right. You see it now? Now 30, anything that is less than 38. Forget about 2 and 3 because this array doesn't exist. I'm sorting this side. Anything that is less than 38 is over here. Anything greater than 38 is over here. Okay? Now I said it's a divide and conquer. It's going to partition the array and then sort the partitions. What should be the next step? What should it sort now? It's going to sort this side now. Okay? When it's done sorting this side, it's going to go ahead and sort this side. It's partitioning, it's breaking. Okay? Now forget about anything else. Now my array is from here to 4. Okay? What will be the partition? What's going to be the next partition? 19. Why is it 19? Because I'm always picking the first number in my array. And what is my array? My array is this. It has kind of reduced. Alright? And that's how quick sort works. So 19 is my array. I'm going to sort from 19 to 4. Okay? 5, the same concept. Anything greater than 19 goes on the right side. Anything less comes on the left side. Okay? 5 stays over there because there's nothing to swap with. Alright, 15 is less, still good because 5 is also less, there is nothing to swap with. 36 is greater than 19, and that's the beginning of the boundary. That all the numbers that are greater than 19 are going to start from 36. Okay, 26 still greater, stays there. 27 greater, stays there. 4 smaller, it should come on the left side, on the green side. What is the number that is going to swap with? 36. Okay, you guys are getting it. Sort with 36. Okay. What's the next step? Swap 19. Because, excellent, my array is this size and it already done it, it stops. There's no, right now I'm just concentrated on this so it doesn't care about the next part. Okay. So my pivot, I'm going to swap my pivot with 4, and everything before this is less, everything after this is greater. You see how it broke down in smaller parts? It's kind of getting to the point where everything is getting in sorting order. Now this part is done. What's the next step? It's going to sort the right side of the array that it kind of ignored at that point. So it's going to start with 46. So these are all sorted. Okay. Right. So this part is done, and again, this is my bad. So it is now breaking down into smaller parts. So sorted this is done. Now these are the 2 parts. Now it has to break the other part even further down to see if those are sorted. Right now you won't see it because these are already sorted. So it kind of checks this part of the array. It's already sorted. Kind of ignores it. Okay. But what happened is, it starts from here, broke down the array over here, then goes here, then goes here until everything is sorted. And then it comes back here, comes back here, comes back here, and then goes. Okay? So I partition the big one, comes to the small one. Right now this is all sorted, so that's why you won't see any changes here until we reach 38. Okay. So now we are on to this part of the array. I'm going to sort this, breaking down into smaller chunks. Greater, this is fine. Less than, move it to 47. Greater, that's fine. Greater, that's fine. Okay. Now I'm going to divide my array, this and this. I'm just going to sort this side of the array, and then it's going to come to this one. Already sorted, so it comes back here. Okay, and this should take one step and it should sort it. Okay, so this is how quick sort works. There are a few more algorithms with the same concept, and this concept called divide and conquer. Again, what is happening? It is dividing the big array into smaller arrays and sorting those chunks. Okay, now this algorithm is called quick sort. Okay, it's sorting a big array. What do you think it is using to sort the small array? It has to use some algorithm, right? What algorithm do you think, sorting algorithm, it is using to sort the smaller array? So this is the array, divides into a smaller array, right? It has to sort the smaller array. It has to use some algorithm.
Use selection.
Selection. Anything else? Huh? Insertion. Huh? Yeah. It's actually using quick sort. It's using itself to sort. Quick sort itself is a sorting algorithm. Okay? What quick sort is doing when it has to sort the smaller array, it just uses itself. Right? Why go and try to find a different algorithm to use to sort it when it is itself an algorithm that kind of sorts it? So the smaller chunks are sorted by quick sort. You see the circle, and this concept is called recursion. Okay? The concept is called recursion. What it means is that it keeps calling itself. Right? It's a very strong and a very useful concept, but you have to be really careful when you are kind of using these concepts, because what will happen is you can go into an infinite loop that you keep calling yourself. So the most important part of using recursion is you need to have a exit strategy. At what point does your algorithm kind of exits out? Okay, that's the important concept of recursion. If you don't have an exit strategy, what will happen is it will keep going, keep calling itself forever. All right. Again, quick sort is part of the divide and conquer mechanism. It divides your array into smaller chunks, and then it sorts those smaller chunks. And what algorithm does it use to sort those things? It uses itself. It uses quick sort. Okay? All right, any questions? You guys want me to do this again? Kind of getting it a little bit. It's kind of difficult concept to get it the first time. But I want you guys to go with a little bit of concept that you kind of get it, because this side, you kind of can follow the same thing again and we'll get it. The more important part of this is that you understand that this relies on partitioning. There has to be a pivot. It takes a pivot or a partition number and then sorts based on that. Everything to the left of that pivot or a partition is going to be less than that. Everything to the right is bigger than that. Start with somewhere in the middle, so that's kind of, let's see. Okay, for example, like 38 was a pivot, so everything less than 38 should be on this side, everything bigger than 38 is on this side. Okay, and you keep doing this until you reach the end of the array and everything is sorted out. Once you have the partitions, you now break it down into smaller chunks. That's how quick sort is. Okay, let me. I'm going to post this solution anyway. Again, the concept is more important. You guys can figure out the code later on. And again, nobody expects. Nobody is going to ask you to write quick sort. But it is unfortunately asked in interviews. People kind of ask, oh, do you know any sorting algorithms, or do you know how quick sort works? Can you kind of pseudo code it out? Nobody expects that you can write that out, but the important part is, you understand the concept. What it is part of divide and conquer, partitions, pivot, these are the kind of keywords that people are looking for when you talk about quick sort. And then what's going on? Right, you're breaking down into smaller chunks and then sorting them out. And what are you using? You're using quick sort. If you're using the same algorithm to sort it, you are using recursion. And this is how it is. You see the function quicksort, it kind of calls itself at some point. Why it is doing it? It's calling the first quicksort that it calls is sorting the left side. When it is done, then it calls itself again to sort the right side of the array. Okay? Logic for determining what's the pivot. You can pick up the first number, last number, or any random number. You guys kind of realize why that's the case? It doesn't matter. We just need a starting point. After the starting point, you know, any number will do as a pivot, right? You can pick 47. Everything less than 47 should be on this side, and then you kind of keep breaking. Starting the first is kind of easier when you are trying to understand this. So that's why I picked it first. Okay. Any questions on quicksort? No, again, the concept, the reason to learn this is so that we know how, again, as I was saying, when you do a computer science degree, the CS 101 or the data structure course, they teach you this. And this is how you build how to create data structures and algorithms. You are never going to come to a place where you're going to say, oh, implement quicksort, okay, quicksort. But you are always going to come up where they will ask you to write an algorithm to solve a problem. Okay, could be kind of similar to this, not similar. It just depends on the use case. But since you know that what it takes to write these, understand this, it will be easier to understand how do you step it out. Okay, and the other part is the complexity. These things, you will see this on Saturday what these mean, but these are what kind of determines how good the algorithm is. All right, if you see quicksort, it kind of ranges from the yellow, this range. It's not over here, so it's kind of better than the two that we saw, insertion and selection sort. Worst case is still worst case is it's a descending array and you want to make it ascending array. But for the average case, and that's the case that you will face most, right? Your array would be kind of unsorted, right? So that's why it's more preferred, because in average case n log n, and that is kind of considered, this range is still better than doing this one. Okay, any algorithm that you write and it comes to this red one is not the right solution. Okay, just remember that. No, it's the brute force solution. So always the easiest solution, but it's part of brute force, but that's not the right solution or the efficient solution. The computer will probably keep running forever. If I put in, you see how for a small set of numbers, it's like this much time. Okay. The other ones we are not going to go through, but you know, these three, if you understand, you can understand the other ones also. But you see there are few more efficient ones. Merge sort is the next one that is more efficient, kind of similar to quicksort. I'm not going to go through it, but merge sort is a good one. Time sort and heap sort. I haven't really looked at it, so I'm not sure. But if I look at it, you know, we can understand what they're doing. But those are kind of more better ones. As I was saying, Chrome uses, when you call the JavaScript sort method, Chrome uses quicksort and insertion sort. If there's a small array, it uses insertion sort. If it's a bigger array, it uses quicksort. Okay. Let's see, what else do I have? Okay, any questions you guys have? I want to give you two more things here. Take a look at, there are, if you guys are interested, let's see, is it here? No. Where did I see that? Yeah. So with the online and everything, like online courses. Harvard and even MIT has some free courses. Princeton has some free courses. The class that I'm sending you, it's from Harvard, and it's the same under the course that I was talking about, CS kind of 101 kind of deal. So this course, if you guys are interested in, teaches you the basic of the data structure that we saw and few more. Okay. Um, you can do it for free. They won't give you a certificate, but I wouldn't worry about the certificate too much. If you guys are interested, this will walk you through. This is like a proper class, and they will teach you the algorithm that we saw, and they'll teach you a few more. And then there's one more course from Princeton. I think the classes are starting next month or something, and I'm going to slide this out too for anybody who is interested more to learn these courses. Take a look at the data structures. Again, if you are interviewing for one of the big fours like Google, Facebook, Amazon, Apple, or something, then they kind of ask these kind of questions. They will ask you to. These are actually considered easier ones than the one they ask. They ask you binary search trees and a few more. So now if you guys are aiming for that, I would definitely look into those questions also, kind of understand those. So these are the two courses. Let's see. What else did I have? Okay. Any questions? Okay. Kind of end of the class. I'm going to stop the